Primary amides, those bearing 2 hydrogens on nitrogen, can be dehydrated to yield nitriles through exposure to one of several reagents. The dehydrating agent may be an anhydride, or it may be thionyl chloride, or it may be phosphorus pentoxide. The mechanisms for 2 of the 3 methods follow. Dehydration using an anhydride begins with the attack of the amide on one of the 2 carbonyl carbons of the anhydride. Much like protonation occurs on the carbonyl oxygen, addition of this electrophile occurs on the carbonyl oxygen as well, because the resulting positive charge on nitrogen is resonance stabilized. This first step amounts to the beginning of a nucleophilic acyl substitution on the anhydride. The anhydride has simply been treated with a nucleophile that we have not used before. As such, a tetrahedral intermediate results. What follows is the loss of the carboxylate as the tetrahedral intermediate collapses. This displaced carboxylate then acquires the proton that will be lost from the positive nitrogen. The first 3 steps of this mechanism have converted the carbonyl oxygen into a good leaving group, and it now dissociates as part of a second carboxylate as the 3rd bond of the nitrile is formed. The displaced carboxylate again acquires the proton lost from nitrogen. Ultimately, the nitrile is the reaction product, and it is accompanied by 2 carboxylic acid molecules as byproducts. Dehydration using thionyl chloride follows the same general motif. The basic strategy of both dehydration mechanisms presented in this video is to convert the carbonyl oxygen into a good leaving group as the pi bonds of the nitrile are formed through sequential loss of protons from nitrogen. In this reaction, the first step also entails the attack of the nucleophilic amide carbonyl oxygen on an electrophile. This time the electrophile is merely the electron-poor sulfur atom of thionyl chloride, and a tetrahedral intermediate is formed, albeit one that we did not see in our videos on nucleophilic acyl substitution. Now that the carbonyl oxygen has been converted to a good leaving group, it dissociates as the 3rd bond of the nitrile is formed. To better understand this process, it might be useful to compare this mechanism to those in the videos on the reaction of alcohols with thionyl chloride and the reaction of carboxylic acids with thionyl chloride. In those reactions, other oxygen atoms are also converted into good leaving groups by thionyl chloride. Finally, the leaving group fragments into sulfur dioxide and chloride. And chloride removes a proton from the substrate to yield the neutral nitrile as the reaction product of interest. Now let's examine a specific example. In this example, benzamide is converted into benzonitrile by treatment with acetic anhydride. The reaction begins with the attack of benzamide's nucleophilic carbonyl oxygen on either of the 2 symmetrical carbonyl carbons of acetic anhydride. This pushes the pi electrons onto oxygen, forming a tetrahedral intermediate. The tetrahedral intermediate then collapses and forces acetate off of the molecule as a leaving group. Next, nitrogen loses a proton to acetate to complete the first half of the mechanism. Remember that the strategic goal of the first half of the mechanism was to convert the carbonyl oxygen into a good leaving group. Now, in the last half of the mechanism, the carbonyl oxygen dissociates as part of acetate as the third bond of the nitrile is formed. And then, the positive nitrogen sheds a proton so as to afford benzonitrile as the final reaction product. In summary, primary amides can be dehydrated so as to generate nitriles. And this is accomplished using an anhydride, thionyl chloride, or phosphorus pentoxide. The mechanism entails the conversion of the carbonyl oxygen into a good leaving group as successive hydrogens are lost from nitrogen to form the pi bonds of the nitrile. The preceding was an excerpt from the book Introductory Organic Reaction Mechanisms, a color-coded approach to arrow pushing. If you found this video to be helpful, you may be interested in the complete book, which is available in ebook format from Scribd, in paperback from Amazon, or in paperback at a discounted price from Lulu.